Hi everyone, my name is Hisham and the title of this talk is What's Next for Teal, the typed dialect of Lua. So let's get into it. I'm going to start by introducing myself. I am Hisham and I have been involved with free and open source software for a long time. I created the HTOP process viewer, the Global Linux distribution, LuaRocks, the package manager for the Lua programming language, and most recently Teal, the Teal language, which is the topic of today's talk. And in fact, this talk is the part 3 of a trilogy, and a trilogy which started with part 1 called Minimalism versus Types, which was my talk at this dev room at FOSDEM 2019. And that talk was a look at the past of all the previous attempts at bringing types to Lua, and back then what was my experiments ongoing around that topic. Around the time that I started to prototype what eventually became Teal, part 2, which had the long-winded title Minimalistic Typed Lua, is here because I didn't have a name for the language yet, so I was just calling it TL at that time. So you can imagine TL became Teal, which was a much nicer name. And at that point, instead of looking back at the previous attempts and the prototype was already a compiler that was actually self-hosting, meaning that I was able to run it to compile itself. So at that point, I was pretty sure that the proof of concept has proven itself. So I was saying that, hey, you can start playing with this and let's give it a try and see what happens, right? So that means that at this point, now that Teal is actually a reality in a sense, now we can start looking at the future. So this is going to be a more forward-looking talk, talking about what's next for Teal. But of course, I'm going to start by recapping and trying to tie everything together about what this journey of getting into a typed dialect of Lua was like. And of course, I need to shout out first and foremost to the fact that as opposed to last year's talk, now we do have an official name. But first, let's step back a little bit and talk a bit about Lua, because I think this is going to help us tie everything together in the end. And also, and don't assume that everyone in the audience is very familiar with Lua. So Lua is a paradoxical thing because it is a widely used niche language, right? So whenever I talk about Lua, I either get two reactions. People go like, oh, of course, Lua, yeah, sure. Or they just go, I have never heard of it. So you might fall in one of the two camps, but do not despair, because I'm going to do like a super quick recap. Well, why am I calling it a widely used niche language? Well, because main characteristic of Lua is being this tiny, small language which can be applied into many different scenarios. So it has been called like the JavaScript of games because it is so popular in all sorts of game engines, big and small, from like huge 3D game environments to like small mobile apps and in like, you know, game consoles and everywhere. Like it's just in the gaming industry, it is pretty much everywhere. It is also super popular in embedded systems and the IoT world. It's used a lot for networking software as well. And it is used inside applications for developing a scripting layer for applications. And often this results in like a good chunk of the entire application ends up being written in Lua. And you may have also seen Lua like embedded in things like VLC and Wireshark and those kinds of things. And also there's like LuaTech, which is this variant of Tech now, which is entirely Lua scripted. And Lua is also the scripting language for Wikipedia, actually. So yeah, so some of the templates that you see in Wikipedia, they are actually scripted in Lua, which is really cool. So why do people use Lua? So generally, it's because of one of three reasons, right? First, because it is embeddable, which means that it is built as a library, which is like super easy to embed into your application. And by being an embeddable library, it is also very small, and the implementation is also pretty fast. And there's even like an alternative implementation with a JIT compiler, LuaJIT, which is even faster. It is extensible, meaning that the language itself is designed with hooks, which makes it easier to extend it and to adapt it to whatever environment it is embedded into. So embedding and extending kind of walk hand in hand. And the third reason why a lot of people end up involved with Lua is simply because something they use, some application that they care about, already embeds Lua. So Lua is the way to have further control into that application, or to mod it, or to extend it in some way. So people end up getting involved with Lua because of that. So one important thing about Lua is that it is minimalistic. It is quite small. The implementation is just a couple of 100K. But it is not minimal, certainly not minimal in the sense of something like, Forth and something of that kind. Because there's a certain pragmatism to Lua, and over time the language has grown, so the language does grow, but slowly. And one thing I have observed over time is that features, they're often added in a logical pattern. For example, for a long time people have asked for bitwise operators to be added. But bitwise operators only got into the language once 64-bit integers were added. So that at that point it made sense to have once you have native integers, but because before that there was a single number type, which was like a 64-bit double floating point. And once native integers were added, then bitwise operators were added instead of doing them in kind of a clunky way over floats. And another main characteristic of Lua is one of its mottos, which is mechanisms, not policies. And that motto has pros and cons to it. And the main one from the pros is that it makes it fit really well as an embedded language in an application, because you can use all these mechanisms to build whatever policies your application needs. But one of the cons is that it makes it sort of not ideal for a pure Lua application in application programming, because you essentially have to rebuild the world from scratch to get your environment going. And also for ecosystem building, because from people who are building libraries for application programming, they're often defining their own policies, which not always play well with each other. And having the language itself not define these policies, for example, how to do object-oriented programming and those kinds of things, that makes it harder. So the end result is that in the Lua world, you end up not with one Lua ecosystem, kind of like the Python ecosystem, if you think of other languages like that. You end up with several often kind of incompatible ecosystems. We could cite for networking applications the OpenResty ecosystem, or the Love2D engine for games, and Roblox, which is yet another game engine which has its own world and own libraries and all of that. So you end up in that situation, which for application programming in general is kind of not ideal. So enter Teal. Teal is a new programming language which defines itself as a statically typed dialect of Lua. So it is, in a sense, an extension of Lua, but not exactly taking one specific Lua version and extending it. But especially since some Lua versions have different incompatibilities between each other. And Teal tries to follow mostly the latest version of Lua. But the compiler itself is compatible with multiple versions of Lua and defines its own dialect of it with its own extensions for specifying types and adding type annotations and those kinds of things. So why Teal? First, because static types are good. They're a great thing for programming the large, application development, those kinds of things. Maybe not super important for small scale scripting, but once you start doing application programming, static types are good. And I won't try to convince you of that. If you're already sold into static types, and you like Lua, you will enjoy Teal. And if not, I'm sure there are tons of talks out there which will evangelize on static types, and I will not have time for that on this one. So you'll have to take my word for it, or just take that as a working hypothesis for the entirety of this talk. Static types are good, but there are tons of statically typed languages already. Why not make another one? Well, I like Lua. And I like working on compilers. So as a personal project, this was interesting to me already. And the third reason, which I think Teal can be useful, is that, well, people, myself included, as developer of Lurox and Kong, a project which I have been involved for a long time, for example, well, people do write quite large applications in Lua, and at that point, it will be great to have static types. So, like Lua, I think Teal tries to be both minimalistic and pragmatic, right? So Teal is pretty minimalistic in the sense that, well, the compiler itself is like a single Lua module, like one tl.lua file, which in fact is generated from using itself from a tl.tl file. So that one Teal file, it implements a Teal to Lua compiler. And that single file, it can be loaded into any modern Lua version from like Lua 5.1 to Lua 5.4, including LuaJIT. And it can be loaded into a project without any dependencies, and it should just work. And once you have that, you can require that module, load the package loader, and voila, you can start requiring other TL files from that, and the compiler would automatically compile them into Lua and load them. And your application will have Teal support from that just by including a single file. And as a language, it is also quite pragmatic. For one, it is not aiming for type theory soundness in that sense, and this is something I have already discussed in the previous talks of this trilogy. So essentially, it doesn't try to be perfect in the mathematical sense of type theory, and in my opinion, it doesn't need to be perfect. It just needs to be better than not having types at all, right? It's important that it does not get in the way, that it doesn't make programming like less pleasant in any way, and also that does not make it more error prone, and it helps you catch errors, and that generally it's just a better experience. So far, I've been pretty happy with it. Like working on the compiler, it got to a point where I started writing it in Lua, and eventually I switched it to Teal. And after I switched it to Teal, not before long, it was like, okay, this is a lot better than the previous stage of development, because now the compiler is actually helping me to work faster on development. So yeah, I think there is a benefit in there. And at the same time, in terms of language evolution, like Lua, Teal is not afraid to add features when they make sense, when they follow a logical pattern, right? So like the first premise of the language was adding static types. And once we had static types, the logical thing was, for example, to have explicit global declarations. And well, we added a keyword, and we added explicit globals. Next thing was another example, when we added union types, then we needed to discriminate on the union types to specify them. So that led to adding the is operator, which was an addition to the language, which Lua originally didn't have. So this allows us to do like compile time comparisons and do some flow typing in there. So we add things here and there when they make sense. We're trying to avoid like gratuitous additions to the language, but generally, when they make sense in moving forward, like its mission of helping programming in the large, I think it makes sense. So where Teal is now, at FOSDEM 2020, we announced Teal 0.1. Then it was just wasn't even called Teal yet. It was just TL. And in this year since, we have seen like a small but growing community developed around the language. Started getting contributions in the compiler itself, but also like around it, like in the tooling department, which is super important. Like a language is not only its compiler, it's not only its like reference, implementation, or definition. Nowadays, a language is nothing without tooling and proper things like editor support, which was one of like the first contributions that we had around it. So now we have like proper editor support for things for Vim, for VS Code, and the other editors as well. We also have an online playground, in which you can write Teal code and see it compile Lua like straight from your browser. It uses Fangari, which is a Lua implementation in JavaScript that runs straight on your browser. And so Teal is like so agnostic to whatever Lua environment he's using. So, and Darren, who wrote the playground, he was able, to drop Teal on top of that and get it running in the browser. So yes, so now you can see Teal running in the browser. We also have Teal types, which is a repository with type definitions of Lua libraries, which has seen contributions from the community. This repo is like similar to typechat for Python, or definitely typed for TypeScript. So for Lua libraries, which are not written in Teal, you have definition files in there which specify which types are used. So you can require Lua libraries from Teal code and they appear typed thanks to those type definitions. And of course, in this year, since Teal 0.1, we have seen a bunch of language improvements as well. And this has been personally my main area of focus. But I have not done this alone. So we have the bunch of language improvements added. Union types got in early on. Tuple types were added as from a community contribution, and like so now we can say that the developer team is growing around the language. Like it's not a one-person project anymore. We have also added meta methods to the language. We have added support for some more recent, like Lua 5.3, 5.4 features, like integer division and bitwise operators with support for meta methods. And they work for all versions of Lua. So even if you're running LuaJIT or Lua 5.1, 5.2, and you run Teal, you get those operators because we generate the proper code for whatever Lua language you're running on. We've had improved flow-based inference, and this is an area in which like there's always like incremental improvements, and it's gradually evolving because right now the compiler is still super simple in that regard. But it already, like for a lot of common patterns that you may write, that the inference already like allows you to not have to annotate some types or do casts or anything like that. And since the language is still in 0.x era, we're taking the opportunity to, based on also user feedback, make some syntax tweaks and cleanups here and there, and just make the language better. So getting to the title of the talk finally, and this is like the most delicate part because I don't want it to sound like vaporware, so but I'll share some of my thoughts on how I see the language moving forward. So what's next for Teal? Well, now I feel it's like really just time to start using it. The language is already being used by people, and we are using this experience to mature the language. Like myself, I want to start using it more in things other than the compiler. And every time I write Teal code, which is not in the compiler, I get some better insights about it. And because it's kind of like, it's important when you develop a language, especially one that it's self-hosted, to try not to end up in the pitfall of writing a language that's great to writing compilers for itself, right? So it needs to be used in more domains. So this is what we've seen from the feedback that we're getting, like as little by little we are identifying what it's missing. But at the same time, if something is missing, it doesn't mean that, of course, we're going to add it for whatever reason. We're always going to try to strike that balance between the minimalism and the pragmatism. So some of the early feedback that we've gotten, and it's still early days in Teal's life, but actually people are already using Teal in production. We are pleasantly surprised when a user showed up in our Gitter chat and mentioned that the product that they're working on in production, it has like more lines of Teal code written than the compiler itself. So there's people out there like writing more Teal code than me already, right? And last month we've had our first community meetup. We got some good feedback for features that people are missing. And here in this slide I put in some of the things that, like, to me sound like good candidates for a near future roadmap. People have been talking about adding like an explicit integer type. Like this is especially useful for people who are using 5.4, but even if they're running older versions, like it would still be nice to have an integer type. It would just not have the precision guarantees, I guess, but this is not uncommon in many languages which support like multiple targets. Another thing that was mentioned was abstract interfaces for records, and also since we have static types, people are longing for optional or require like functionality, so that the compiler would tell them if they forgot an argument in a function. And this leads to a more open question regarding nil safety, which is harder to pull off. And if we go the path of TypeScript, then it would lead to even less soundness in the language. And then it's a question whether we really want to go that direction. I think it's worth experimenting and seeing where we get there. But that one, I put like more of a question mark. But yeah, I think there's going to be a lot more discussion about it this year. And if we as a community can find a solution for it, then it would be great, because, you know, nil is infamously the $1 billion mistake, right? In every language that has it. But since this is a talk meant to be forward-looking, I'd like to share a thought that I think it's a bit more philosophical. As Teal evolved, I believe that in order for it to keep true to the minimalistic and pragmatic spirit of Lua, it needs to take a page from Lua in one crucial aspect. Like Lua, Teal is embeddable, right? You can embed it into any Lua environment. Like once Lua is already in there, it's like trivial, you load like one more Lua file and Teal is there. But it also needs to be extensible, right? And the reason I think that, because this is like the only way to avoid having the language grow indefinitely, because type systems evolve, people's needs change. You know, today's like sort of esoteric feature may be tomorrow's mainstream feature, right? Maybe if Teal was created like, you know, a while ago, like now it has generics, and might like in the past not have generics, and who knows what people are gonna expect like as a baseline, you know, a while from now. And even like for people with specific needs, which is one of like the main interesting things about Lua. If you have a very specific need, you can just extend it for your specific need. So a view of like how to do that. Like, so this is how I see a path for extensibility in Teal. Once we consider extensibility in Lua, we see that, you know, Lua has meta tables and meta methods that are evaluated at runtime. And another source of extensibility is its Lua C API, right? Those are like advanced functionality. Like, know that this is generally handled by the embedders, like the people who integrate Lua into an environment or into an application, and not by the scripters or like the developers who write the bulk of like business logic code in Lua, right? So Teal needs support for extensibility as well in some sense, you know, and a good parallel for that would be metaprogramming at compile time. And for that, it would need sort of like a compiler API, so that, you know, the metaprogramming that you do could like, you know, introduce new types and those sorts of things, and then, you know, have its own evaluation rules for type relations and those sorts of things. And compile time metaprogramming is like a topic I've been interested for a long time. You know, my undergrad dissertation a long time ago was actually on compile time metaprogramming, so it will be fun to get back into that topic at some point. And well, extensibility and embedding, you know, they walk hand in hand. These meta features from Lua are often used to make Lua fit into an application, like or an ecosystem. So Teal's meta features, you know, can be a solution for easing its integration into existing Lua environments as well. So in short, well, Teal is usable today. I invite everyone to give it a try. It provides an embeddable static tidying support for Lua-based environments. It provides what I consider to be important functionality for programming in the large, you know, type support. And well, it's a new language. It is evolving. It has a welcoming community. It's a great opportunity to contribute. It's a great opportunity to be involved in compilers and programming languages and all this sort of fun stuff. So thank you. And once again, I extend the invitation for you to, if you're interested, you know, drop by our Gitter. It has also Matrix Bridge, and so you can join by either Gitter or Matrix, you know, and say hello. We hang out there. And there's links for, you know, all the things at our Teal repo. And this is what I had for the talk, and we're going to switch to the Q&A session now. Thank you.